Okay, in this demo here, we're going to show rapid failover. We're just pinging Google. So, like, people have done this to check their internet connection. You open up a command prompt, ping 8888. That's Google's public DNS, and it's always up. And if you could reach that, then you have an internet connection right there. And what I've done is I've set aside 2 laptops on 2 separate internal LAN networks on my demo box that I built. And what I'm doing is just, I'm pinging Google. And then I'm going to disconnect the Fios connection, which is what they're both using. And I use a Traceroute to show that early in the video. You're going to see that Fios is the path to Verizon. Our other circuit is basically owned by Comcast, so it would say Comcast in the path. But when I break that connection, you're going to see that single drop and ping, and then immediately resume pinging Google again, because what happens is it's failing over to my MPLS link, which has a default route that's been leaked into it. So we're going to show this right here, and I hope you enjoy it.
All right, everyone, welcome back. And now, having deployed the webinar demo appliance previously, I went ahead and set up this lab to represent a branch office with just 2 networks. As we showed in the onboarding demo, we have dual paths to our data center and to the web over Fios, shown here in green. And this wire is connected over here to our Fios gateway, right there. And then on the other side in red, we have our MPLS connection, shown there, and that connects back to our data center, back through the wall port there. Now, I'm going to demonstrate how Versa deals with a hard failure on the path and fails over to our MPLS link. This way, you'll see both machines running a constant ping to Google, and we're going to show you that here in just a second.
Okay, and here we are inside our Versa controller. This is known as the director. And inside here, we have our webinar demo that we deployed earlier. Just go back into this template and let's review a few things real quick. Under the interfaces portion, you see we have our first internet connection. It was just plain internet. And it's through DHCP via Fios. And we have our MPLS link, which is the secondary port. And that appears as port 1 on the device. Now, the Fios connection, again, is DHCP, and we get that straight off the Fios gateway, but the static connection is pre-delivered by the carrier, and in our case, it starts with 107. We have monitoring, so what happens is the device looks at 8888, and when it sees it disappear, it fails the default route over to the other. We're using Fios as the primary route for that currently. Now, within the network LAN, which would be internal to the branch, we have a couple of IPs that we're using here. They are both static for gateway, and the devices themselves are going to receive 2 separate networks, and the office users are going to receive 192.168.112 as their space, and this one here is 192.168.111. Now, that's not really significant, but you'll see that show up on each PC and Mac that I'm using here for the demonstration. So let's get to that demonstration, and I'll be right back.
Okay, we're back. We're going to resume this process. Here you see the Macintosh. It's got the 192.168.112.10 address. And over here on the PC, it's going to be tough to see, but let's try. 192.168.111.10. So they have 2 separate networks they're running on, and represented here by the yellow for the PC and, of course, the blue for the Mac. The switch has no other connectivity to it. As you can see, it's just working as an access switch right now. And again, to review real quick, this is a Fios connection here in green, and then underneath is our MPLS with a default route that we've leaked into that for demonstration purposes. So I'm going to go ahead and remove this, and we're going to watch the Traceroute real quick. Let's see what that returns. Really try to focus this in so you can see the path. You should see Verizon show up there right in about the middle. That's our Verizon path. Again, we're going out over the Verizon link right here. And same thing over here. Now this, unfortunately, won't be quite as fast as the Mac. Resolution's a little bit slow on PCs for some reason, but this will eventually show us what we need to see. If my camera will stay focused. There it goes. There we go. You should see Verizon in that statement. Okay. So again, these are both using the Verizon path. And now what I'm going to do is engage the extended pings. And you can see it's running at about 15 milliseconds right there. And let's get this one running. And this one's going to vary probably between 13 and 15 milliseconds. Now here comes the fun part. I'm going to unplug this default path, and both of these are going to have probably 1 or 2 drops apiece and then immediately fail over. So there it goes. Lights out, and there's a failover, and there's a failover. Right? Now this happens with the minimum of configuration. Versa assumes that this is a desirable situation, that when you have 2 links, you want to see an instantaneous failover, and that's what we have right here. Now, I want to plug this back in, and you'll see the link light come back online. All right. Now, what's interesting to watch is, as you can tell, you're seeing that latency go way down because of the MPLS link. I'm going to keep this trained on there. Well, it happened. It's going to happen sooner than I'm expecting. I bet. It's going to fail back over to the Fios link, which is historically, between 12 and 15 milliseconds. So just like that, it's already failed back to the default path, which is what we want, because we don't necessarily want MPLS feeding internet, throughout the environment, because it's an expensive link and chances are we don't have that much bandwidth. But it's intended for failover for internet path. So again, I'll just do this one more time. Drop the Fios link. We'll get our timeout. In this case, we got a couple of hits here, but that's a fairly rapid failover. And the funny thing is, folks, this is the default setting. This wasn't anything that we tweaked. We can actually tweak this to be more rapid, but in most cases, this is going to work for web traffic to the point where people will probably not even notice that occurred. So thank you for watching, and I hope you enjoyed the video.
Hey, that was pretty cool. You had mentioned at the very end that you can tweak those, voice over IP, and I noticed a couple things that, like, your Fios connection was 14 millisecond, and the MPLS connections were like 8 milliseconds.
Right.
For sensitive applications like voice over IP, could you dictate them to always go over a specific transport circuit versus the other one?
Yes, we can. And that's important. That's really important to draw that out in the conversation here, because that was a very generic demonstration to really show that failover. But when you're talking about a voice connection, if you were really running voice at the branch and you were backhauling it to your data center, right? If you have 2 links, the best thing we could do is not just rely on a simple failover scenario like that, but to do forward error correction and data striping. That's something we can do within the Versa system that basically takes voice traffic. We can do it one of 2 ways, really, but this example, we're sending that voice packet twice across both links and sending it back to the data center across 2 separate paths. The Versa appliance head-in unit will take that flow, look at it, and those packets are going to come in on a time slice. It's going to look at those time slices, and again, this is happening in microseconds. This is processor level things. So my voice talking about it right now seems like it's taking forever, but the computer systems in there, in the chips, they do it, faster than we can possibly imagine. So it takes those packets and reassembles them on the backside. It stitches together the best flow it can make, and that's the best way to run voice, for example, which is very latency sensitive and packet drop sensitive at your branch. So you could send those packets as duplicates across both paths, and on the inbound side, it reassembles them based on their timestamp and makes the phone call, agnostic to what's happening on the WAN, whether it be jitter, whether it be a failover, whatever it may be. Because let's face it, on any given circuit, there may be periods of time of high amounts of latency. There could be issues upstream that we don't know about and very hard to detect from a simple, BFD or some sort of IPSLA standpoint. This is the better way to do it. But to your point, yes, we could actually say, hey, we want voice just to go over MPLS. And in the event of a failover, sure, use the other one and go over the tunnel. But, it depends upon the situation. But the cool thing is we could do it either way. I hope I answered your question.
I think so. And a couple more things here. One is I saw in the demo itself that you had a single box.
Yes.
I assume you could put in multiple boxes with multiple links, and a follow-up with that is the flip side. I have a super small location that only has one link. Does SD-WAN buy me anything there? And is there any other ways of backing up that single circuit, maybe with like a cellular connection or something?
Absolutely. Both, yes, to both. So it was interesting when I started to look into this, and I said, well, what about the high availability side of this? Because that may be a requirement for the business. And not every place needs it, right? I mean, it just depends. But if you need high availability, Versa is actually easier to set up a high availability pair than it is an active passive. And that is contrary to most environments in most appliances. High availability in a small branch device is very difficult to achieve. I know this from experience, and this is something that Versa does relatively easily. So that's one angle. Yes, you can do high availability with a pair of Versa boxes, and it won't break the bank. That's the better part. These boxes really aren't expensive at all, and the licensing to enable that isn't expensive either. The other part of that is that most Versa appliances come with the ability to snap in an LTE card, like a SIM card, that's configured for this. And you can actually fail over your device to an LTE 4G and soon 5G connection. So you don't want that running all the time, to your point, right? You probably have some sort of agreement with a local carrier, and it's a couple $100 a month for your circuit. But if you need to fail over to LTE, it's there, it's available, and it can sit in standby. We can deprioritize that link so that it doesn't do anything except to receive and send control traffic. And then in the event that something happens, you can fail over to that. And yes, it'll probably be at a reduced rate, but you'll still be up. You can still get emails, and you probably could still make phone calls.
Wow, sounds great. Sounds great. So to follow up on the end of this, let's do a quick recap on what we saw. So I'm gonna jump in and talk for a minute about this, and let Sean, I'll do the top level and let Sean dive into the expert level. So what I've seen is we get some ridiculous visibility from the security layer using Checkpoint all the way down to the circuit or transport layer. That's pretty cool. Being able to throttle stuff, and it helps us improve our business continuity. Getting it implemented and installed, zero-touch provisioning, that sounds great. I'd love to see that in action.
Sure.
And then availability, basically what I just heard in the last slide is we can make this as available as possible, or from a single circuit with the backup of LTE up to redundant boxes and redundant links.
Yes.
Being able to prioritize the proper applications, especially with the applications moving out to the cloud, where your data and your applications are no longer in your data center. It's really cool how it can be prioritized. The one thing I didn't see on here, and we talked about a little bit, was cost savings. That being able to collapse that stack, having multiple devices moving into one, being able to eliminate high cost MPLS connections because of the traffic that's now going across there wasn't never anticipated. And putting more commodity-based connections in sounds like a great solution for this. My question to you, Sean, is if you had to pick one of these, I know it's difficult. If you had to pick one of these, what would you think would be most important or the best takeaway for the people who are listening today?
Man, that's tough. That's probably the hardest question of the day, because there's so many components of this that I like. And it's one of the things I tried to show here in this series, but really, I guess if I had to pick something, I'm getting a single pane of glass for the network. Networks were always decentralized, where everything was kind of running on its own. It was its own unique snowflake. Even though it was part of a bigger system, everything was still, maybe some folks from the past deployed these branches over here, and folks that came along later deployed these branches over here, and there's just so much differences between them. They still work, but it isn't homogeneous, and it's not something that's easily managed, right? This gives you that single pane of glass to manage the entire environment. Once you get it started, once you get it rolled out, adding a branch, it's so easy. And that's expansion. That's growth of the business. If you're not growing, you're dying. You've got to be able to grow. And this idea that it takes months to do, that's hogwash. That shouldn't be the case. This eliminates all that, right? Plus, you get to collapse that stack into something that's more manageable. You have less, I don't want to call anybody out particularly, but licensing fees and, equipment and so on. You're paying so much money for all this stuff when really what you want to do is you want to have it work well. And that's what this does. This steps in, it works really well. The cost savings, if you want to talk about in terms of dollar signs, you're talking $4 signs compared to $1 with Versa, right? I mean, you go to lunch on vacation, you look at the dollars, how much does it cost you to get lunch? This one's $3, this one's $1. Well, if one works for you that day, go to one. This one works. It just works.
So one final question, and I'm going to review some of the other questions that I saw, but while I'm reviewing those, I'll let you answer this one. And the question is, it sounds like Versa does a lot. How does it do it all on one box? Is there a secret sauce? Is there like an underlying something or another that they use to make us be able to do multiple things on a single box?
It's proprietary information. They have this Versa Flex VNF, and that software package in combination with the controller, which is redundant in our case. We have one on Amazon East and Amazon West Coast. That's what does it. It's the box itself is relatively simple. It's it's basically what they call a white box, and that is a trend that's growing in networking as well. White boxing your network at the access layer, the distribution layer, and in some cases even the core layer. That's becoming a trend too, and they leverage that. They leverage it very heavily because it's the software that makes it work. It's not the box itself.
That sounds good. So I think we're going to close out. I'd like to thank everybody for joining today. We will make this webcast available for review. We will also make the demos individually available for anybody to take a look at. If you have any questions or would like to follow up with us, please give us a reach out. Both Sean and my contact information is available at the beginning of this recording. Thanks a lot and have a great day.